So we covered basic bullet stability in another video. That's basically how to give your bullet enough stability out of the muzzle to fly true at long range. Now, what happens when the bullet slows to transonic speed, or when the bullet slows to about 1,340 feet per second? It's getting close to the speed of sound, getting close to the sound barrier, and that is a bad place to fly for anything. And in particular for bullets that are spin stabilized, what the sound barrier does to a bullet as it flies at that speed is it has a destabilizing effect. The center of pressure moves forward, the overturning moment on the bullet gets greater, and the question is your bullet going to have enough gyroscopic stability to overcome the increasing dynamic instability that's experienced at transonic speed? Some bullets do this better than others. Typically bullets that are shorter and have shallow boat tail angles will track better through transonic range. On the contrary, bullets that are longer, they can experience a great range of pitching and yawing in the transonic range that will depress their ballistic coefficients at that speed to greater or lesser extents depending on the exact conditions of the day, which will make it very hard to predict your trajectory for bullets like that through that speed range. It's important to know that the basic knowledge that you need to select the correct twist from the muzzle through supersonic range, that's really just the beginning. When you look at transonic effects on stability, you're looking at reasons to maybe have a super fast twist rate to stabilize your bullets, because you're actually getting better performance. You're getting less drag and more BC from your bullets if they're spinning with a more rigid axis through the transonic flight range, because they'll be experiencing less pitching and yawing in their flight. So this short video is just meant to give you some exposure to the ideas that you're faced with transonic stability. The best resource to read more about that is Modern Advancements in Long-Range Shooting. The first volume of this series, we looked extensively at twist rate, and I'm not talking about an academic look at the subject. We've got a lot of barrels that we've shot with different twist rates, different rifling profiles, and we've shot these through supersonic range and transonic range, the same bullets through many different barrels. And we've studied specifically the effects of twist rate on muzzle velocity. Does fast twist rate really slow your muzzle velocity down? The effects of twist rate on basic precision. What are the effects on group size? The effect of twist rate on supersonic and transonic ballistic coefficient. A lot of gunpowder was burned to get these results, and it's all published in layman's terms that are easy for long-range shooters to read and understand how it applies to their shooting objectives. So, if you're interested in learning more about transonic stability of spin-stabilized bullets, Modern Advancements for Long-Range Shooting.